Hello friends, I will think about next lecture, electric potential, part 10b. In the previous case, that means part A, we discussed very important topics like electrical potential energy of the system of charges in presence of electric field. Now, today we'll think about some very important numericals of chapter number 2 from you can see the NCERT department. So 4 to 5 numericals we would like to cover today in second part. All numericals are very IMP. Few numericals are very important, particularly for JEE NEET point of view. So we'll start with we can say that number 1. So just concentration required. Here what is the data? So we discuss we can say that with data also. So just concentration required. You can also consider your textbook, no doubt about it. So this is your unsolved number 19. So this is from additional exercise. If one of the two electrons of H2 hydrogen molecules is removed, we get a hydrogen molecular ion H2 plus in the group. So in the ground state and H2 plus, the two protons are separated by roughly 1.5 angstrom. Two protons are separated. This is your 2.19 for 3 marks question. You can see here these are the two protons, E plus, E plus. If two protons are separated by roughly 1.5 angstrom and electron is already at a distance of 1 angstrom from these two protons. This is you can see that distance 1 angstrom from these both protons. This is your electron you can see. So what's your target? So your target, you know that 2.19, you can take the reference. Then what is the, we can say that potential energy of the system, and specify your choice of the zero potential energy also. So here first of all, in which circumstances the zero potential energy of the system of these three particles? Obviously these three particles are situated at infinite distance. So you can see we can write here for zero potential energy state, separation of given particles, or I can write given particles are separated infinite distance. For zero potential energy state, when given particles are separated at infinite. So we know that very well. In this state we obtain zero potential energy. So this is the state. Now in this state, that means for given situation, so total potential energy in that state or in a given state, potential energy of system U is equal to, now be alert, already 1, 2, 3, these are the three particles, and you have idea about the shortcut. How can you find total potential energy of the system of these three charges? First of all, start with the first particle. First particle form a pair with 7 as well as third. You know that total potential energy is the algebraic sum of all potential energy, or I can say that algebraic sum of potential energy of all possible pairs. तो ये जो फर्स्ट पार्टिकल है यानी फर्स्ट प्रोटॉन, ये दूसरे प्रोटॉन के साथ और ये इलेक्ट्रॉन के साथ पेयर बनाएगा. सो टोटल पोटेंशियल एनर्जी U is equal to, I can write from here, potential energy of system U is equal to U12 plus U13. 1 का टका 2 के साथ, 1 का टका 3 के साथ. Now number of 2. So 2, 3. Obviously U23 system of, you can say the 2 and 3. Third already 1 के साथ है, third 2 के साथ भी है. So now write down the formula. What is the formula of the system? Or I can say electrical potential energy of the system of two particles. It is already K. I can write here Q, but electron. So proton. So QP into QP, and charge of proton multiplied by charge of proton divided by distance between them. It is 1.5 into 10 raised to minus 10 angstrom. Then U13, यानी कि energy of system of these two particles 1 and 3, one proton, one electron. So I can write K charge of proton, charge of electron upon distance between them 1 angstrom. Then 2, 3. So 2 and 3, just take it 2 and 3. It is proton electron again. So K charge of proton, charge of electron upon 10 raised to minus 10. It is also 1 angstrom. Check the data very carefully. Here already K charge of proton and charge of electron remain same. So K charge of proton and charge of electron, you know that same, and directly we can set up the value. It is 1.6 into 10 raised to minus 19 the whole square. Now you understand what I have done here. Here charge of proton, charge of electron, इसका फॉर्मूला होगा e square और एक स्टेप ज्यादा लिखते हैं ताकि पता चले. So e, so e square, so k square common, so remaining portion, and also 10 raised to minus 10 also common. So remaining portion inside the bracket 1 upon 1.5, but here charge of electron is negative, so here minus 1. Be alert about this charge of electron. Now here also charge of electron, so minus 1, because 10 raised to minus 10 common. Now you understand. So, but this answer already in the form of joule. If you read data very carefully, then they mention your answer should be required in the form of electron volt. But K 9 into 10 raised to 9, E already 1.6 into 10 raised to minus 19 the whole square, here 10 raised to minus 10. If you simplify 1.5, sorry, 1 upon 1.5 minus 2, already minus 2, and into 1 upon 1.6 into 10 raised to minus 9. What I have done here, if you divide this term joule by E, that means divide by 1.6 into 10 raised to minus 19, so joule is converted in the form of electron volt. Electron volt is the smallest unit of energy, and 1 electron volt, you know that 1.6 into 10 raised to minus 19 joule. So that's why this is the punching point here also. If you simplify, then you will get answer in the form of 19 point something. Okay, so this is, you can see that your first question, this is your 2.19 now, question number 2.19, and very interesting point. What is the, we can say the 2.19, so you have to just think about in opposite way. 2.19 becomes 19.2, and your answer electron volt, but it is in the form of negative, because here minus 2 if you think about LCM, so minus 19.2 electron volt, and obviously minus sign suggesting bound state. These three particles, that means 2 protons and 1 electron, already in bound state by considering, or we can say that because of this energy. And if you would like to remove these all particles at infinite distance, then you have to supply the same amount of energy but in the form of positive, plus 19.2 or more than it, then these all particles can become free from the ground state. So very interesting point. This is your number 19 textbook IMP numerical, just analyze. You can see here simply we have applied the formula for the electrical potential of the system of charges in absence of electric field. Now you think about the next number, most time before JW need. So be alert about it. Most important numericals in this part number B. Okay, so just question number next. ये क्वेश्चन बहुत ही इंटरेस्टिंग है और IMP बनने वाला है. So हर एक बंदा है वो अच्छी तरह जरा देखे. There are, you can see that this is your 2.20, but I will write here NEET JEE. Very interesting for these two examinations point of view. So just concentration required. These are the, we can say that two spheres are already shown. I have represented in, we can say, the different size, because the radius of the first sphere it is small a, and the radius of the second sphere it is small b. That the charge on the first sphere is q1, charge on the second sphere is q2, and they both are, we can say that, connected by means of wire. Anytime two charged spheres are connected by means of wire, then after removal of connection, you know that very well what happened. They both possess equal amount of charge. Then obviously potential becomes same. मैंने आपको ये एक शॉर्टकट ये हमने असाइनमेंट वर्क का सॉल्यूशन में डिस्कस किया था जेडब्ल्यू नीट असाइनमेंट. When two charged spheres are, we can say that, in contact by means of any conducting wire, then obviously one quantity becomes common or same. So just concentration required here. You can see. So here due to connection, electric potential on spheres, or I can say that at both spheres are equal, or I can say that will be equal. Ready? So let the potential on the first sphere is V1, potential on the second sphere is V2. So V1 is equal to V2. Okay, so V1, you know that very well. What is the potential on the surface of this sphere? Spherical shell. Then whatever the charge is distributed, it can be considered at the center. So Q1 can be considered the center. So what is the potential at this point or at the surface of the first sphere because of Q1 charge? Obviously it is KQ by R, but here KQ1 by R1 already radius, it is A, is equal to potential surface of sphere B or sphere 2. So it is KQ2 upon radius B. KK cancel. So Q1 upon Q2 is equal to A by B. From this equation you can see that the charge on a sphere is directly proportional to the radius. You can see this is the most IMP shortcut, but in which circumstances whenever potential on these both spheres same. So this is your JEE NEET concept. Don't forget, I will write here for same potential, always charge on sphere is directly proportional to radius. Charge is directly proportional to radius, but in which circumstances whenever potential on both spheres already equal. Now the second stage most IMP. So just concentration required. Initially or in the first case you obtain relationship between charge and radius. Now we would like to discuss electric field. That the electric field on the first sphere is E1 and electric field on the second sphere is E2. So what happened here now? So first of all, E1 electric field on sphere 1 and E2 is equal to electric field on sphere 2. So what is the formula of electric field? If charge is considered at the center, then what is the formula of electric field? Obviously, if you consider charge at the center, then electric field due to charge it is KQ1 by, anybody, KQ by R square, but here A square. So KQ1 by A square and here KQ2 upon B square. So these are the electric fields on both spheres. So if you take ratio, so E1 upon E2 is equal to, if you take ratio of this both, that means KQ1 upon A square upon KQ2 upon B square. So E1 by E2 is equal to obviously B square by A square and first of all Q1 by Q2, B square by A square, you know that mathematical moment, B square by A square, but Q1 by Q2 is equal to A by B. So E1 upon E2 is equal to A by B multiplied by B square by A square. So E1 by E2 is equal to B cancel, A cancel, it is B by A. And you can see here electric field is already, electric field is inversely proportional to radius, EA, E to B. So this is the most IMP point. But in which circumstances, again, you can see that for this type of situation. So electric field, most IMP relationship, don't forget, for same potential, you can see what about electric field is inversely proportional to radius. और ये shortcut related MCQ हमने discuss किया था. जो लास्ट पेपर में भी था, मोस्ट इंपोर्टेंट पॉइंट. नाउ यू थिंक अबाउट द थर्ड केस. Third case in terms of surface charge density. You know that there are three types of densities: linear charge density, surface charge density, volume charge density. What do you mean by surface charge density? It is called charge per unit area. So you consider, let sigma 1 and sigma 2 are surface charge densities at both spheres respectively. For example, here surface charge density sigma 1 and surface charge density for the second sphere is sigma 2. So what's the formula of sigma 1? What is the meaning of surface charge density? Charge per unit area. So what is the charge on first sphere? Q1. What is the curved surface area of the sphere number 1? It is 4 pi r square, but here a square. So it implies that charge Q1 is equal to sigma 1 multiplied by 4 pi a square. Similarly, sigma 2, you can see sigma 2. Sigma 2 is equal to Q2 upon 4 pi but b square. It implies that charge on second sphere, it is sigma 2 multiplied by 4 pi b square. So now we take the ratio of sigma 1 to sigma 2. So sigma 1 upon sigma 2, if you take the ratio, then what happens? Here simply you can see, डायरेक्ट भी रेशियो ले सकते हैं, मगर अपन लोग चार्ज के फॉर्म में लेते हैं या सिग्मा के फॉर्म में लेना तो भी ले सकते हैं. इधर अपन लोग सिग्मा 1 का सीधा फॉर्मूला डिप्लाई कर सकते हैं. सिग्मा 1 by sigma 2, it is simply q1 upon, you can see 4 pi a square upon q2 upon 4 pi b square. It gives, you can see, q1 upon q2, 4 pi cancel, multiply by b square by a square, b square by a square. So final answer, sigma 1 upon sigma 2 is equal to sigma 1 upon sigma 2 is equal to q1 by q2. q1 by q2 already with us, it is a by b. So a by b multiplied by b square by a square. So sigma 1 upon sigma 2 is equal to again b by a, like you can see that electric field. So it gives, or it implies that you can see for same potential, you know that very well, surface charge density is inversely proportional to radius. This is also Dhum formula for this scenario. You can see that for same potential, these are the three most handy shortcuts. Once again, two charged spheres are connected by means of wire. Then obviously, first of all you can see that potential on both surfaces will become equal. That means potential becomes, we can say that, common quantity. Then for same potential on both spheres, number 1, charge is directly proportional to radius. Number 2, electric field on the surface of sphere is inversely proportional to radius. And you can see that surface charge density is also inversely proportional to radius, most handy point. And this is very interesting point. ये किस तरह है surface charge density, जरा देखते हैं. Surface charge density gives idea about the distribution of charge per unit area. इसीलिए अगर आप देखो, so whenever if you think about the large PD, generally large PD is developed at sharp surfaces. हमने देखा होगा कि कोई भी दो शार्प सरफेसेस के बीच में जबरदस्त पीडी प्रोड्यूस होता है और वहां पे स्पार्क जनरेट होता है. फ्लैट सरफेस पे स्पार्क जनरेट होने के चांसेस बहुत कम होते हैं, मगर शार्प सरफेस पे स्पार्क जनरेट होता है. अगर मैं आपको एक एग्जांपल दूं, ये परफेक्ट एग्जांपल है कि अगर आप मल्टी स्टोरेज बिल्डिंग पे हो, खास करके जिसे कह सकते हैं कि मॉनसून की सीजन में, और अगर आप मेटेलिक वायर है, उसका एक एंड है वो कंक्रीट के अंदर रख दो या कंक्रीट के साथ बांध दो या उसके ऊपर कंक्रीट है उसको सेटअप करो, और जो दूसरा एंड है वहां पे कोई मेटेलिक है वो तीर लगा दो, वो यू नो दैट, और उस तीर को अगर आप रेनी सीजन में ऊपर फेंकते हो तो लार्ज पीडी डेवलप होने के चांसेस शार्प सरफेस पे ज़्यादा हो गए, और वो पीडी के कारण लाइटनिंग है, बिजली है, वो पीडी बहुत ही ज़बरदस्त लेवल पे कंक्रीट है उसको रप्चर कर देगा. पीडी डेवलप होने से अपन लोग जानते हैं स्पार्क, ये हमने देखा होगा. अगर आप जिसे कह सकते हैं कि सिंपली टेस्ला लेबोरेटरी में जाते हो, वहाँ पे ऐसे लाइव एग्जांपल्स भी दिए गए हैं. So most important point. So why sharp surface? Simply you can see they plays very important role. And why at sharp surfaces PD is developed, we can say that in considerable amount and spark is generated between two sharp surfaces. So it can be obtained from this point. If you consider this type of point, you can see. So there is sharp surface. So if you think about this radius, you can see here radius very small, only this radius you can see. And that's why here charge is deposited in large quantity, because radius and surface charge density are in inverse proportion. So I can write for sharp surface, obviously for sharp surface, R is, we can say that decreases. R decreases, obviously surface charge density increases, that means very high. But if you think about flat surface, for flat surface, R you can see that increases. For example, this surface. So if you think about radius, you can see. So radius is very high. So radius you can see that increases. So what happens if the surface charge density decreases? That means low value of sigma. तो यहाँ पे चार्ज है, ये देखो क्वांटिटी जोरदार, जबकि यहाँ पे चार्ज है बहुत ही कम होगा. सो यहाँ पे पीडी डेवलप होने के चांसेस ज्यादा है क्योंकि यहाँ पे चार्ज ज्यादा है. इसीलिए ऑलवेज शार्प सरफेस है, यू नो द चिमनी, त्रिशूल, यू नो दैट दिस ऑल concept based on this point. Sharp surface, large quantity of charge deposited because of this reason. This is the concrete reason behind this logic, you can see. So most important point we have discussed, very interesting point. Once again, what are the 2 to 3 punching points for JEE NEET? This is your unsolved number 2.20, 20 number question of your textbook, but it gives very important few, we can say the logical points. Number one, whenever two conducting spheres or charged spheres are in contact, then potential always remains same. Number two, potential becomes equal, then 3 points are very empty. For two charged spheres, if potential are same, then number one, charge on the sphere is directly proportional to radius of the sphere, you can see. Number two, electric field is inversely proportional to the radius. And surface charge density, very important, surface charge density is inversely proportional to the radius. Very empty point. And because of this concept, at a sharp surface, radius decreases, surface charge density increases, large amount of charge is deposited. While at flat surface, radius increases, surface charge density decreases, and very low quantity of charge is deposited. And you know that very well, that's the reason between two sharp surfaces PD is developed very high, or high PD or large PD is developed and spark can be generated. So very interesting point we discussed 2.20. Now we move towards the next point. You can easily consider the complete screen, just check it. Most important 2.20. Now we move towards the next. This is also very IMP numerical, and I can say whatever we can say the sample question paper sent by, we can say that board, whatever the numerical we will discuss, this numerical already we can say that available in this sample paper. So be alert for 4 marks. ये 3 मार्क्स के लिए आएंगे. सो मगर इसका मेन इंपॉर्टेंट आप जानते हो कि जेडबल नीट के लिए भी बहुत ही जबरदस्त. नाउ वी विल थिंक अबाउट द नेक्स्ट नंबर सुप्रीम. सो जस्ट कंसंट्रेशन रिक्वायर्ड, it is very important for us. So question number 2.21. So very IMP. अब इलेक्ट्रिकल पोटेंशियल एनर्जी अपने पास बहुत सारे कंसेप्चुअल पॉइंट है, सब अप्लाई करते हैं अपन लोग. सबसे पहले पोटेंशियल ड्यू टू चार्ज से शुरू करते हैं. जनरल फॉर्मूला पोटेंशियल. व्हाट्स द जनरल फॉर्मूला पोटेंशियल? पोटेंशियल दैट मींस वर्क डन पर यूनिट चार्ज. सो वर्क डन इज इक्वल टू QE. आफ्टर दैट वी डिफाइन और we obtain the formula for potential due to charge. What's the formula of the potential due to charge? It is KQ by R. After that you know that dipole. Then we have discussed very important point, potential difference. Then equipotential surfaces, potential due to charge in the spherical cell. Then electrical potential energy, relationship between electric field and potential. And electrical potential energy, then there are 3 cases. Out of these 3 cases already we have discussed 2. Number 1, electrical potential energy of the system in absence of electric field and electrical potential energy of the system of charges in the presence of electric field or electric field. So ये सभी concept का use करके अपन लोग एक कदम आगे बढ़ते हैं. So 2.21 very IMP. So just concentration required. First of all, this type of three-dimensional coordinate system given Z, X and Y. Ready? This is positive Z axis, this is negative Z axis, and these are the two charged particles, plus Q, minus Q. Obviously, two charged particles, you know that very well, equal in magnitude and opposite type. Two equal and opposite type charges separated by finite distance. Then always these two charges form a dipole. This is your simply, I can say, dipolar. You can see. So this diagram simply indicating now dipolar. Now this is origin point 0, 0, 0. There is, we can see the 0, 0, A. This is 0, 0, minus A. Okay. And we would like to find potential at this point P. At the distance of this point P from origin point is Z, और coordinates polarity 0, 0, Z. यानी कि origin point से P point पे अपने को फाइंड करना है क्या पोटेंशियल. अब अपन लोग तो ये सब अच्छी तरह जानते हैं, फिर भी इसको जरा अच्छी तरह डिस्कस कर लेते हैं. क्या जानते हैं उसका आंसर आपको पता चलेगा. ओके, जस्ट कंसंट्रेशन रिक्वायर्ड माइनस Z. सो इलेक्ट्रिक पोटेंशियल एट पॉइंट P, it is V is equal to, here potential is produced because of these two charges. So I can write K Q upon, what is the distance of this point P from plus Q charge? This distance already A, this distance already small a or small a, that means total 2a. You know that total distance between two charges for length of dipole 2a. So what is this distance? Anybody? So you know the total distance ZA, so obviously Z minus A. So I can put here Z minus A plus. What is the potential at point P because of this minus Q charge? Minus Q charge. So it is already minus KQ upon this distance. So already here A to Z, and it is Z plus A. So KQ common. So remaining portion Z minus A 1 upon Z plus A, you know that. Now what's the next move? It is obviously LCM. So what is the LCM? Z plus A, Z minus A, Z plus A minus Z, but because of this minus, you know that plus A. ये आप जानते हो क्या हो रही है इधर, Z cancel. So final answer V is equal to, or BP potential at point P is equal to KQ. So KQ, and what's the final point? It is, you can see that A plus A 2A. So answer 2A upon Z square minus A square. But you know that 2AQ. So 2AQ into K upon Z square minus A square. So it is K into P upon Z square minus A square. And if Z double greater than A, you know that very well. If Z double greater than A, then potential at this point P, you know that A square is neglected. So Kp upon, you know that here Z square. So A square is neglected. So Kp by Z square. And you know that this is the potential due to dipole on which axis? On, you can see that axial line now. So ये जो न्यूमेरिकल है उसका पहला पढ़ा हमने डिस्कस किया. हम वापस जिसे कह सकते हैं कि पूरा डेटा डिस्कस करते हैं क्योंकि ये थोड़ा लेंथी प्रोसीजर है. So first of all, what is the electrostatic potential at the point 0, 0, Z? And another part also given x, y, 0. First of all, potential at point 0, 0, Z, and another point given x, y, 0. You can see. So first question already we have discussed. Just a minute. Okay. Yes. First point already we have discussed. Now we have to think about x, y, 0. What is the potential at x, y, 0? X, y, and 0. So where is x, y, 0? So this is, you can see that x axis. Now be alert. This is, you can see, is a simply geometrical concept, and this is y. So obviously somewhere here, this is your xy0, sorry, xy0 z coordinate 0. We would like to find potential here. अब ये जो कहानी है उसको अच्छी तरह किस तरह डिस्कस करना है वो मैं इधर एक्सप्लेन करने जा रहा हूँ. ओके, so you can see three axes, z, y and x. Ready? So this is your z axis, this is your y, and this is x. We would like to find potential in xy plane. This is your xy plane, x and y. This is your xy plane, and somewhere here. अब ये point है आपके पास. But here potential is produced due to two charges. Check these two charges, plus q and minus q. But this plus q and minus q already located on which axis? Available on which axis? Z axis. So मैं अब x को और y को थोड़ी देर के लिए भूल जाता हूँ. You can see that. And here z axis. This is your z axis. Here plus q charge. Here minus q charge. This is your dipole in short. And your xy point here. Here आपने xy point. You can see this is x axis, y axis. This is your xy0 point. And now concentration required. This is, you can see the positive charge. And मैं पूरी z axis को थोड़ा और extend करता हूँ. Like in this way. Like this one. This is, you can see the plus, minus, and there is, you can see that x. This is y axis, x axis or x y. So there is xy0 point here. Suppose this point is a sub. So I would like to find potential here. But here potential is mainly produced due to this plus q charge and minus q charge. So what is the distance of this point S from plus q charge? This is distance, you can see. Ready? And what is the potential at this? What is the distance of it? So at this point S. मैं इस तरह नहीं बताऊंगा, ना लोचन ऐसा मैं बता रहा हूँ ताकि आपको पता चले, क्योंकि इधर y axis है, इधर x axis है और ये xy plane है. What is the distance of this point from this negative q? It is also same or not? You can see that ऐसे होगा. ये मैं बताता हूँ, देखो परफेक्ट. सो ये अपना सीन है, ये प्लस z एक्सिस, ये माइनस z एक्सिस, इधर x होगा और जिसे कह सकते हैं कि इधर x होगा और इधर y होगा और x y प्लेन. अब यहाँ पे पोटेंशियल फाइंड करना है, तो ये प्लस q का पोटेंशियल इधर होगा और माइनस q का पोटेंशियल, ये r होगा तो ये भी r होगा क्योंकि दोनों इक्वल डिस्टेंस है. तो दोनों का चार्ज देखो q, दोनों का डिस्टेंस भी देखो सेम, मगर ये प्लस q चार्ज है, ये माइनस q चार्ज है. व्हाट इज द पोटेंशियल एट दिस पॉइंट S because of this plus q charge at a distance r, kq by r. And what is the potential at point S because of negative charge? It is minus kq by r. So I can write here simply electric potential. Now electric potential at point xy0 बराबर. कहानी अच्छी तरह समझनी हो तो मैं वापस इधर एक्स्ट्रा डायग्राम ड्रॉ कर रहा हूँ. ये प्लस क्यू चार्ज है, माइनस क्यू चार्ज है और कुछ इस तरह की कहानी बनेगी. इसको कृपया ये y एक्सिस मत समझना, इसको अच्छी तरह 3D में ड्रॉ करना हो तो देखो ऐसे होगा. तो मैं आपको जरा जिसे कह सकते हैं कि 2D में नहीं, ऐसे 3D में. ये ऐसे you can see this is plus q charge, this is minus q charge और ये आपका xy प्लेन. ये अगर आपको मैं ऐसे ड्रॉ करूंगा तो आपको ये दूरी और ये दूरी है थोड़ा डिफरेंस लगेगा, मगर एग्जैक्ट सीन होगा ऐसे. देखो ये डिस्टेंस ये रहा xy प्लेन, ये प्लस q चार्ज, ये r होगा. इसी तरह ये होगा माइनस q चार्ज, तो ये भी r होगा और ये पूरा सीन इस तरह बनेगा. तो इधर पोटेंशियल होगा सेम. सो आई कैन राइट obviously suppose this point is a sub. तो देखो ये डायग्राम में इधर ड्रॉ कर रहा हूँ, इसको अपन लोग पॉइंट S कह देते हैं, xy0. तो ये डिस्टेंस सेम होगा, मगर 2D में इसको समझना थोड़ा मुश्किल, इसलिए मैंने 3D बताया. सो इलेक्ट्रिक पोटेंशियल एट पॉइंट xy0 इट इज सपोज VA sub. So here kq by r, this is r minus ये भी डिस्टेंस क्या होगा r. So minus kq by r. Why minus it? Because negative charge. So answer होगा 0. So what is the potential at any point in xy plane? It is 0. So this is your first target of question number 2.21. ये question 4 मार्क्स में damn sure पूछेंगे. अब आता है इसका second point. What is the second point? Obtain the dependence of potential on the distance distance r of a point from the origin when r by a is double greater than 1. Obtain the dependence of potential on the distance r of a point from the origin when r double greater than a. अब r double greater than a के लिए डिस्कस करना है. So first of all we write here, you can see. So second part B. Okay. अब अपने को जिसे कह सकते हैं कि पूरा सीन तो हम जानते हैं, बिकॉज व्हाट इज द फॉर्मूला ऑफ पोटेंशियल ड्यू टू डाइपोल. सो पोटेंशियल ड्यू टू डाइपोल, याद करो जनरल फॉर्मूला, बिकॉज दिस इज नथिंग बट डाइपोल. सो व्हाट इज द फॉर्मूला ऑफ द पोटेंशियल ड्यू टू डाइपोल? सो पोटेंशियल ड्यू टू डाइपोल V is equal to 1 upon 4 pi epsilon naught P cos theta by r square. But here we would like to find upon dependence in terms of distance. So obviously V is inversely proportional to, simply you can see that square of the distance. Very handy point. तो ये direct answer आ गया. Potential is inversely proportional to the square of the distance. So this is your second part. Now you think about the third one. Third one very important. So don't forget, third one is very handy. Third one, how much work is needed in moving a small test charge? Now there is a test charge from the point 5002 minus 700 but along the x-axis. Obviously 500 to minus 700, and thus the answer change if the path of the test charge between the same points is not along the x-axis. Okay, so what is the scenario? Just concentration required. First part already we have discussed. अब जरा मैं वापस से डायग्राम में उसको करेक्ट कर देता हूँ, थोड़ा आपको पता चले इस तरह. ये सब हटा देते हैं. You can see only dipole with us. Here this distance a, this is a, there is negative charge, this is plus q charge, and this is z axis, this is your dipole x axis and y. So what is this axis? Obviously negative x axis. So this is your negative x axis, this is your पॉजिटिव एक्स एक्सिस. सपोज अपन लोग जिसे कह सकते हैं, अभी मैं इस तरह ले रहा हूँ, बाकी आप कंसीडरेशन में लो. फॉर एग्जांपल एक्स वाई जेड पॉइंट ऑफ व्यू में अपन लोग इस तरह जाए तो भी, अगर हम लोग कोई भी एक्सिस को भी देखें तो 500, सपोज दिस इज योर पॉइंट 500, समझ लो. अगर हम लोग उल्टा समझे, ये प्लस एक्स और ये नेगेटिव एक्स एक्सिस, नो प्रॉब्लम. सो हियर दिस इज योर 500 बिकॉज 5 पॉजिटिव, and there is you can see that minus 700. अब अपने को यहाँ पे से there is you can see the test charge suppose q naught. Test charge is situated at point 500 and we would like to move this test charge from point 500 to point 700, minus 700 along this x axis. So अपन लोग तो जानते हैं टेस्ट चार्ज को ले जाना हो तो वर्क डन का फॉर्मूला. So work done W is equal to simply charge multiplied by potential difference between two points, two endpoints. तो यहाँ पे potential suppose A point को अपन लोग कह देते हैं M. This is point N. We would like to move this charge, test charge Q naught from M to N. So obviously charge Q naught, and what is the potential difference? It is Vm minus Vn. Let the potential at this point M, it is Vm. Potential at this point N, it is Vn. तो सबसे पहले अपने को Vm और Vn फाइंड करना हो, तो what's the we can say that Vm और Vn. वापस कहानी देखो, this is your dipole. Here a dipole positive. This you can see that this cap represent plus q charge, this cap represent negative charge. अब पहली कहानी ऐसे थी, देखो y, ये z और x. अब मैं अपन लोग x किधर है, देखो दिस इज योर x. ऐसा देखते हैं. सो दिस इज योर वी कैन से दैट x एक्सिस, ये z है, ये x. यहाँ पे आपका ये पॉइंट है minus 700. यू कैन सी लाइक इन दिस वे minus 700. और इस साइड अपन लोग एक और कदम आगे बढ़े. सो दिस इज यू कैन सी दैट positive x axis. यहाँ पे आपका 500 है, ये रहा, समझो बराबर। ये y एक्सिस है, ये x एक्सिस है, यानी कि में देखा जाए तो ऐसा अपन लोग ये 3D में देखा जाए तो ये इसको मैं थोड़ा ऐसा पलट के आपके सामने है। अब आप देखो ये z एक्सिस, यहाँ पे प्लस क्यू चार्ज, यहाँ पे माइनस क्यू चार्ज, ये x एक्सिस, यहाँ पे आपका है 500, यहाँ पे आपका -700 और ये एक्सिस है y एक्सिस, जो भूल जाते हैं। अब यहाँ से चार्ज को यहाँ ले जाना है, ऑब्वियसली यहाँ से चार्ज को यहाँ पे ले जाना हो तो अपन लोग ने जो कंसेप्ट अप्लाई कर दिया, दिस इज योर पॉइंट एम, दिस इज एन, here vm, here vn, so what is the potential at this point? vm फाइंड करना हो तो ये प्लस q का चार्ज और ये माइनस q चार्ज, what is this distance? if you think about right angle तो ये हाइपोटेन्यूज सेम बनेगा। in short I can say distance of point m from plus q charge and from minus q charge will remain same story here। अगर n की दूरी देखें तो प्लस q से और माइनस q से सेम होगी, so no problem at all। so I can write here vm is equal to, यहाँ पे जो पोटेंशियल जनरेट होने वाला है ये प्लस क्यू का और ये माइनस क्यू का, ये डिस्टेंस तो सेम है, अभी मैंने बताया, इसमें कम पता चलेगा 3D में। सो व्हाट इज द पोटेंशियल के क्यू बाय आर, ये आर माइनस के क्यू बाय आर, दिस इज पोटेंशियल ड्यू टू नेगेटिव चार्ज, सो आंसर 0। सेम स्टोरी हियर, पोटेंशियल एन, सो के क्यू बाय आर माइनस के क्यू बाय आर 0, सो vm vn 0, so obviously total work done required also 0। And one more question here they ask, if you consider any other path, that means we would like to move this test charge from 500 to -700 but not along x axis, via any other path, then what happens with the work done? Now this is conservative field, you know that in conservative field work done doesn't depend upon type of path chosen, that means work done remain same 0। so this one is the most lengthy question, 2.21, 4 marks, most important point। here you can see the important point diagram, so you have to think about diagram, don't worry about we can say the representation, इधर चाहिए जब आमने सामने तब एक बार और अपन लोग डिस्कस करेंगे। तो ये जो न्यूमेरिकल्स हमने डिस्कस किए सभी के सभी मोस्ट टाइम पे न्यूमेरिकल्स है। एक और न्यूमेरिकल है वो अपन लोग जिसे कह सकते कवर करते हैं, जिसे वो नेक्स्ट लेवल पे देखेंगे, क्योंकि मोस्ट प्रोबेबली जिसे कह सकते हैं कि ये सभी न्यूमेरिकल्स इंपॉर्टेंट है। तो होमवर्क में जिसे कह सकते हैं हम लोग देखते हैं डे टू डे आपको 1 आवर का एक्स्ट्रा वर्क करना है, उसमें जितने न्यूमेरिकल्स चले हैं वो सब न्यूमेरिकल्स अब आपको लिख के लर्न करने, प्रिपेयर करने, कंसेप्चुअली जो पॉइंट्स आता है वो देखना है ताकि स्ट्रॉन्ग बने। थ्योरेटिकली जो पॉइंट्स है वो भी मैं कल डिस्कस कराऊंगा कि इतनी आईएमपी थियरीज है नेक्स्ट टेस्ट के लिए। वंस अगेन आपके जो फ्रेंड्स है जो भी है उसको भी आप रेफरेंस दे सकते हो, किसके लिए अभी ये जो टाइम है उसमें एजुकेशन के लिए। और दूसरी बात है आप लोग के पास बहुत सारा टाइम है अभी, सो प्लीज फ्रेंड्स डोंट वेस्ट योर टाइम, यूज ईच एंड एवरी मोमेंट। नेक्स्ट लेक्चर विल डिस्कस वेरी इंपॉर्टेंट पॉइंट्स। थैंक्स।